Saxon's Trig, lesson 41, is about reciprocal trigonometric functions and permutation notation, starting on page 293. So the first part is reciprocal trig functions, and we know that our basis, 3, are sine, cosine, and tangent. And again, I constantly use the so, ca, toa to help me remember what those stand for. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So when we do their reciprocal, we know that that word means to flip them over. So when I flip over the sine one, I'm basically getting hypotenuse over opposite, and I want to know what word that actually means. For cosine, it's going to be hypotenuse over adjacent. And I'll give you that word in a moment. And then the opposite here will be, oh, and also TOA, we know, we learned the other day, I believe, was sine over cosine. So when you flip it, you're going to get cosine over sine, or you would have the adjacent over the opposite. All right, so now what words go with these? So the opposite of sine is cosecant. Now the way that I remember this is that it has the S in the middle, which matches with the sine, the S starting with sine. The opposite of cosine is secant, and it has an E in the middle, no matching letters, and so that helps me there. And then tangent is super easy. Its opposite is cotangent. And because the word tangent is in there, that's an easy one to remember. So if I have an easy to remember, tangent goes opposite of cotangent, and I have an S in the middle that matches with sine, kind of by default, then I can remember that secant goes with cosine. So you definitely want to jot those down as you are memorizing those. Now the book does start with the fact that another way to write the opposite of cosine is to say it's 1 over cosine. The opposite here would be 1 over sine. And of course the opposite here would be 1 over tangent. Those are all acceptable formats for reciprocal. All right, in example 1, it says, draw the appropriate triangles and evaluate secant of 330 degrees plus cotangent of 480 degrees. Now you'll notice, I'm just going to kind of mark that off so we know it's not part of what we're currently working on. You'll notice that I am dealing with some degrees that are less than 360, some that are more than 360. I'm now dealing with the new words with secant and cotangent, but this method of addition is the same thing that we've been doing over and over and over. You're just incorporating this new wording that we just now have, but everything else is the same as we've been doing. So let's graph 330 degrees. 0, 90, 180, 270, 360. I'm shy of the 360 by 30 degrees. Opposite the 30 is 1 because of the quadrant -1. Adjacent's the radical 3, hypotenuse is 2. Secant is the opposite of cosine. So we're, instead of doing our ca, we're going to pull hypotenuse over adjacent. So hypotenuse is 2, adjacent is root 3. Then our plus sign from here, and now the cotangent of 480. 0. Oh, I first noticed that I'm going past 480, 360 degrees, so we're going to subtract that off. So 120. All right, so we've graphed all the way around once, then 90, 180. Oh, didn't quite reach 180. How much short of the 180 is the 120 that's going to here? That's 60. Opposite the 60 is root 3, adjacent is 1, according to the quadrant, -1, hypotenuse is 2, and then it wants cotangent, which is the opposite of tangent. So instead of doing opposite over adjacent, it's adjacent over opposite, so the adjacent is -1 over the opposite, which is root 3, and now we need a common denominator. Oh, we have it. So 2 minus 1 is 1 over root 3. Now, you may question, why didn't you go ahead and fix those? I could have. It's just since they were already the same, it was just as fast to do that and now fix it. But you can do the opposite fix this one, and then combine them. So multiply by root 3 over root 3. That's going to give us root 3 over 3. Flip the page. Yep. All right, example 2. Draw the appropriate triangles and evaluate 2/3 cosecant of negative 3 pi over 4. Oh, now I see that they're giving it to me in radian on top of the other things. Secant 11 pi over 4. So we have the extra step of changing these over to degrees before we can do the graphing. So negative 3 pi over 4, and again, I don't need to worry about that negative. We're going to multiply by, we need pi to cancel, so it goes in the bottom. 180 is its matching. For conversion, pi's will cancel. 4 goes into 180 45 times. 45 times 3 means that this is negative 135. Let me check myself there. 15. Yes, okay. So now we know we need to graph negative 135. And I'm going to go ahead and write that 2/3 parenthesis, anticipating that answer, and then minus, dropping down. All right, so negative 0, negative 90, negative 180. Okay, it was shy of negative 180 by how much? 45 degrees. Means negative 1, and root 2 is memorized. And then cosecant is the opposite of sine, which was so we were looking for hypotenuse over opposite. So the hypotenuse is root 2 over the opposite, which is negative 1. And I know there's some fixing we can do in there, but we'll come back to that. Let's go over here and do our conversion of 11 pi over 4. Again, we want the pi to cancel. We'll use 180. Pi's cancel off. 4 goes into 180 45 times. 45 times 11. Faster on a calculator, I know. So 495. So when we go to graph 495, I see that I'm wrapping all the way around to minusing 360. I'm running out of space to cram these numbers in here. Minus 360. 135. All right, and it was, just making sure it wasn't negative. Okay, it was not. So we've graphed 360. Now we are going another 135. So that's just shy of the 180 by 45 degrees. Negative 1, positive 1, root 2. And then we're working on secant, which is the opposite of cosine, which was the ca. So we're going to pull, nothing to multiply with, hypotenuse, which is root 2 over adjacent, which is negative 1. So now let's fix things. Positive times negative is negative. 2 root 2 over 3. Minus and minus changes it to a positive. Root 2 basically over 1. I don't need it. But to put this together, I do need a common denominator. So I'm going to change this to 3 and 3. This is a root 2, this is a root 2. They are like terms, so negative 2 plus 3 is 1 root 2 over 3, or basically just root 2 over 3. I don't really need the 1. Example 3. Draw the appropriate triangle to evaluate secant of 10 pi over 3 plus cosecant negative 7 pi over 2. All right, need to convert. So our 10 pi over 3 needs to multiply by the pi to cancel, 180. 3 goes into 180 60 times. 60 times 10 is 600 degrees. So we have secant of 600 degrees. While I'm at it, I'll just go ahead and do, ignoring the negative, so plus cosecant of negative something in degree. So 7 pi over 2, the pi, the 180 cancel off, 2 goes into 180 90 times. 90 times 7, negative 630 degrees. Now we're going to graph 600. So we have definitely wrapped 360 around. oops, couldn't really read my 6 there, 240. So I've wrapped 360, 0, 90, 180, 270. I didn't reach 270, so how much past the 180 did I go? 60. Opposite that will be the negative because of the quadrant, root 3. This one is also negative, hypotenuse of 2. And I'll go ahead and finish that. So secant, just write our SOHCAHTOA so you can see it again. So we know that secant is the opposite of cosine. So we're going to do hypotenuse over adjacent. So the hypotenuse is 2, the adjacent is -1. The plus is dropping down. Now let's graph our 630. Now that's definitely more than 360. Seven. And then 2, okay, so 270. Oh, all right. And this one is a quadrantal one. So we've gone negative all the way around using down to 270. So then this is -90, -180, -270. Ooh, so this is the actual line I'm stopping on. So I have a fake triangle, which is why I said, it's a quadrantal. So I am moving up, yes. I am not moving over because I'm stuck on this line, and that hypotenuse has to match the length of the side. Now, cosecant is the opposite of sine. So hypotenuse over opposite is what we're looking for. The hypotenuse is 1, the opposite is 1. And this is basically -2 plus 1, so that gives us -1. Yep, checking that answer on the next page. Example 4. Draw the appropriate triangles and evaluate cotangent of 17 pi over 6 minus root 6, cosecant of -9 pi over 4. Yeah, okay. Here we go one more time. Convert 17 pi over 6 with the pi and the 180. Pi's will cancel. 6 goes into 180 30 times. 30 times 17. 5, is that right? 510? Did they quickly give me that? Or are they're working on a calculator with radians. Okay, hang on, let me just try to triple check myself. Yeah, okay, I feel fairly confident about that. All right, so what we have is cotangent of 510 degrees minus root 6. Cosecant of, and I know it's going to be a negative degree of some sort, so 9 pi over 4, pi to cancel, 180, 4 goes into 180 45 times, 45 times 9. I want to say 405. Just a second, try to do that again in my head. I think that's right. Okay, so then this would be 405 degrees. Graphing 510, that's definitely 360 used around once. All right, so 150. So all the way around, 90, 180. All right, so it's shy of the 180 by 30. Opposite 31, adjacent root 3, negative because of the quadrant, hypotenuse 2. Cotangent is opposite of TOA, so we want the adjacent, which is the negative root 3, over the opposite, which is 1, minus root 6, multiplying with whatever the other answer is. That's graphing negative 405, which is, again, past the 360. 45. Okay, so you can see why doing this on the calculator is a lot faster than my trying to do the calculations in my head. But the 0 all the way around backwards to the 360 plus another 45 more puts us in quadrant 4, 45 degrees, -1, 1, root 2. We are using the word cosecant, opposite of sine, so hypotenuse over opposite. Hypotenuse is root 2, opposite is -1. So this is basically negative root 3. This negative and this negative are going to turn into a positive. Root 6 times root 2, root 12. These are not, well, I'm going to have to simplify that anyway. I could have left them separated at 6 and 2 because that's going to split into 2 and 3. Either way, this becomes 2 and 2. So I have a set of 2's pulling to the outside. Negative root 3 plus 2 root 3. Oh, now they sure like things. Negative 1 plus 2 is 1 root 3. So it should just be root 3. Finally, now we get to move on to part B, which is the permutation notation. Now, in just a couple of lessons ago, or super recently, oh, hold that thought. All right, so we were talking about the permutation notation, and we just did permutations the other day. It was how many combinations, when we did the lines and we filled in how many different numbers, and then we multiply each of those individual ones as the counting number information tells us to multiply those all together and get your final answer. So in example 5, it says, how many permutations are there of 22 things taken 6 at a time? So basically it's telling you you've got 6 lines. In the first one, you've got 22 choices. What does it say about generalize this answer to an expression for n things taken r at a time? So it wants you to use this to figure out the formula rather than the book telling you the formula. So since it doesn't talk about repetition, I assume there is no repetition. So only 21 choices now, then 20, 19, 18, and 17. So if I'm trying to get a formula or a shortcut, we would be doing something like 22 factorial, but we don't want 16 and down, so we're dividing that off. So in a formula, if I say n is the number of items and r is the number that I'm choosing, then I can create, so the n, the number that I have is 22 for the top, so that would be n factorial over, and then how did I get to the 16? Oh, n minus r, and we also factorial that. And then the other piece to the formula is that you have a capital P, which is standing for permutation, and then n and r. So the number that you have to choose from is first, and the amount that you're choosing is the second. So this is the shortcut formula for permutation. Now that you have it, they ask you to do example 7 and find P choosing 4 items. So rather than doing the lines, you're just going to do 12 factorial divided by 12 minus 4 is 8, 8 factorial, and then basically you're either doing that on your calculator or 12 times 11 times 10 times 9. You lose the 8 and down, and however that works out to be, which happens or should be 11,880 because you're doing it on your calculator.